This is Math 2, 4.3 notes. That's Unit 4, Lesson 3. The title of the notes is Angle Bisector, and we're going to talk about the angle bisector theorem, which states if a point is on a bisector, I'm going to leave space here to draw the picture. If a point is on a bisector of an angle, then it is equidistant from the sides of the angle. What does that mean? All right, let's draw a picture. So we have an angle. We'll call this angle A, B, C. Okay, so if a point is on a bisector of an angle, so let's draw our bisector. So we have this angle and we bisect the angle, which means you cut the angle in half. So if you cut the angle in half, that means first off that those two angles are congruent because you bisected the angle. Then it is equidistant from the sides of the angle. All right, so any point on this, so if I pick a point there and I'm going to call that point D, it is equidistant to point C as it is to point A. These two segments here will always be congruent. And that is true for any point. I could have put the point here and connected. Now I put right angles here because when you are looking at distance between two lines, you always look for the perpendicular distance. You don't just randomly pick longer distances. Between two lines, you pick the perpendicular distance. So if I were to pick a point here and there, those would be congruent as well. Any point on the angle bisector. Okay, the converse is also true. So if I have a picture like this with these two segments congruent, then I know that this line here is the bisector, the angle bisector. All right, moving on. We're going to throw another vocabulary word in here, and it is called the incenter. It's a word you will need to know, the incenter. All right, the incenter is the point of concurrency of the angle bisectors of the angles. The point of concurrency of the angle bisectors of the angles of a triangle. So, any triangle you have, and you draw the angle bisectors. And you draw the angle bisector. Now, here on this image, I'm just kind of eyeballing it. If you were to get construction tools and actually do this the proper way, you would see that all three angle bisectors intersect at one point, and we call that the point of concurrency, and that point is called the incenter. Incenter. to go through some quick examples. Number 1, find FB. Find FB. All right, so let's draw a picture. Okay, this is going to be C, B, and I'm going to try to fix this one more time. C, B, D, and we're going to draw this line coming out here. And there's certain markings I'm going to give you and certain markings I'm not. I'm going to give you those markings. So we know already that this line here is an angle bisector. I know it doesn't look very nice, but best we can to make it look like an angle bisector. Okay, I'm also going to give you this point here, F. I'm going to give you that that's perpendicular and that's perpendicular. I'm going to label this segment here, FD is 4x plus 9, FB is 6x minus 3. And I want you to find the length of FB. Okay, notice there's no markings here, but if a point is on the bisector of an angle, so here's the angle bisector, point F is on the angle bisector, then it is equidistant from the sides of the angle. Equidistant, so those there are congruent. Those markings were not given to us, but we can conclude that from the angle bisector theorem. So we can say that 6x minus 3 equals 4x plus 9. Subtract your 4x. 2x minus 3 equals 9. Add your 3. 2x equals 12. And divide the 2. Now be careful here, especially if it's multiple choice. X equals 6. If it's multiple choice and this is like letter A, 6, and you mark it, or if it's an open response and you put 6 on the test, I would mark this wrong. You'd get partial credit, but you would not get full credit because I'm not asking to find X, I'm asking you to find the length of FB. So just be careful with that. We plug it in, this is FB here. So I'm going to put FB equals 6x minus 3. And then we're going to take the x that we just found, which was 6, and work it out. You get 36 minus 3. FB equals 33. So be careful. Make sure you read and know what you're looking for. Okay, number 2. Find the measure of KHL, the measure of angle FHL, and the measure of angle KHF. All right, let's get the image. This is K, this is F, this point there is L, and I'm going to connect HL. And again, there's certain markings I'm going to give you and certain markings I'm not. I'll give you that this is perpendicular, that is congruent, and I'm going to give you that this little angle there is 6y degrees. And this little angle there is 4y plus 18 degrees. Okay, so they gave us no markings here at all. So how do we find y when we don't know what's going on here? This is the converse of the angle bisector theorem. The converse is if these two are equidistant, if those two sides there are congruent, if they are equidistant, then this point lies on the angle bisector. So if these two are congruent, then L lies on the angle bisector. So it didn't give us those markings, but we have enough information to know that those two little angles are congruent. Converse of the angle bisector theorem. So if you have something like this on the test, those are congruent, then you know that this line here is indeed the angle bisector theorem. 6y equals 4y plus 18. I want to get the y's to one side, so I'm going to subtract 4y over. That gives us 2y equals 18. Divide y equals 9. Now what I want you to do is find the measure of each one. The measure of angle KHL is 6y. Plug it in. You'll do that on your own. The measure of angle FHL is this angle here. 4y. Oh, the measure of angle, I didn't write it down, FHL equals 4y plus 18. You're going to plug y in there as well. And the last one, find the measure of angle KHF. KHF is the big angle, the two of them put together. I'll let you figure out what to do on that one. So work it out, and we'll compare answers together in class. That is it for this lesson.